Welcome to Mastering Solutions. In this question, we're told that excellent human jumpers can leap straight up to a height of 110 centimeters off the ground, and to reach that, what speed would a normal person have to leave the ground? So let's write a list of the variables that we're given. Delta y, in this case, is going to be 110 centimeters, but that's not standard units, and let's convert it over. With centimeters, that's 10 to the negative 2, so we can move this over 2 places, which will give us 1.1 meters. And then we also know that gravity is the only acceleration, or negative g, which is equal to a negative 9.8 meters per second squared. And let's see, that is all that we're given. So now we need to figure out what variable we're going to be using. And for this, the variable is going to be velocity final squared is equal to v initial squared plus 2 times the acceleration times the delta y. Now this is the one that we're using because we have to find an equation that has all of the variables that we'll be using, and in this case we'll be using all the ones that we're given with the one that we're looking for. In this case we're looking for the initial velocity. We can simplify this equation a little bit more because we know that the final velocity as a person jumps, we're only going to be looking at half of their jump. So as they come up here, and then they stop before they come back down. So right there, the split second where they stop in the midair, that is where we'll be stopping our equation. So final velocity is 0. So we can subtract over the initial velocity squared. So we have minus vi squared is equal to 2a times delta y. If we multiply everything in the equation by negative 1, now we'll have the variable that we need. So we have velocity initial squared is equal to 2a delta y, and that is negative. You could also notate that negative 2 or negative a or negative y, as long as one of the variables is negative, that will give us the correct answer here. So now we need to square root both sides to isolate v initial because we want v initial, not v initial squared. So v initial is equal to the square root of negative 2 times the acceleration times delta y. And so now that we have our equation, we can just plug in our variables to this. So velocity initial is equal to the square root of negative 2 times the acceleration, which we said is negative 9.8 meters per second squared, times delta y, which we said is 1.1 meters. And now let's go to our calculator and plug this in. So we have the square root of negative 2 times negative 9.8 times 1.1 meters, which gives us 4.64, so we'll round that to 4.6 meters per second, which will round to 4.6 meters per second for the speed that a normal person would have to jump to reach that height.